Hello everybody, welcome to CS202 Online. So today we are going to be reviewing for the exam, and also I want to cover a couple of things before. So we'll probably spend maybe like 20 minutes on class material and then jump right into the review. Okay, so I'll make it very brief. So hope you're all doing fine. What my plan is for this video is that I'm gonna try to upload it as soon as class ends and make it public, but no guarantees, I suppose. So if somebody doesn't watch the video now, you can always watch it on Twitch immediately after while it gets uploaded. All right. So what I'll do for the review is I will answer questions first, and then I will go ahead and end the recording, but I'll stay on to answer, to kind of go a little bit over the test, and that'll just be on Twitch. That way I can start uploading the class material stuff. So yeah, I think that's the plan. Also, I am giving a test right now, so there's a small chance that I have to pause like the stream if I see like major panic going on for that test that I'm giving up right now. So I will keep monitoring Discord and other places to see if there are issues with the 302 test that I'm giving out. Fingers crossed, hopefully they do good. Right? It's fingers crossed is for good luck, right? Not for bad luck. Yeah, for good luck. Okay. So, okay. So instead of writing code, what I want to go over is this accessing private stuff and then function pointers. So I'm just going to show you code because it'll be a lot faster, I think. By the way, I already updated the code that I wrote last class. I immediately added it. But I don't review the test though. The TS review the test, to be fair. So here, this is all from Canvas, so you can follow along. So let's start with this code here. So I have a link to IDE 1. It's a sample code. I'm going to post it here. And this is how to access private variables. This will be a good review of pointer arithmetic as well. Okay. So this code, all right, there we go, right there, is from IDE 1. This is a link. I also posted it on the chat, and if I remember, I'll post it on the YouTube video as well. But if not, there it is. And so you can actually hit fork on here and play around with it. So that's what we'll do in a minute here. So anyways, I have a class which has a constructor. Good review for the test. Let's talk about how this constructor is made up, right? Because I know some people had issues with this colon situation here. So this is a default constructor because it doesn't have any parameters in the constructor itself. Now, what is this part? So when you see the colon, you'll see this colon before you actually see the curly braces, which indicate the body of the function. What this means is initialize this variable x, which is a class variable right here, with the value of 5. Now I'm hard coding that. I am literally hard coding it so it's always initialized to 5. That will be the equivalent if I wrote here x equals 5 in here, or if in the body of the function here I wrote x equals 5 semicolon as well. All right. Same thing with the 4. Now, what could I do is, if this was not a default, you know what, let's do forks so I can actually do these things instead of just talking about them. So here we go. So now this one that I'm making will have a different link, which I will post as well, okay? So, by the way, be very careful if you're ever using these kind of things to work on your assignments, because this stuff, whatever I code here is completely public. My dog is angry that I'm talking. It will be completely public, and so you may accidentally give away solutions or things like that, so be very careful about that. You are able to set your code to private or secret, which means that it's still public, but you need a link and it's not searchable on Google. It's okay, but it's not ideal, so just be careful about doing this for assignments or things like that. But anyways, I usually use this a lot when I'm teaching in class, because I can write code and very conveniently in any computer that has a browser, and then there's a link so everybody can download the code on their own time. They don't have to write it down. So it's very nice for when I'm teaching in person, actually. But here, of course, it's nicer too because I can just save the files in my own computer. Alternatively, I can use a laptop, but yeah. So if I had something like int var in here, okay, this means that I have now a parameter in this function, okay. Now what if I want to hard code that to 5? I can do that, but this is just a local variable in the function. Now instead of assigning always 5 to the x variable, I'm going to go ahead and say var. So what this does is it initializes the class variable x with whatever var contains. By default, if I don't specify anything, so if I do something like this, var will contain a 5, which means x will contain a 5. However, if when I do this function here, I say like 4, and maybe 2, then now x will contain a 2, okay? So that's important to know. Okay, so I think I can still leave it like that, and the rest of this code will still work. So yeah, we'll leave it like that. Okay, so you separate these initializations with a comma as well. So that's some good review right there. Okay, this is known as a setter function. Again, this is review. This is a get. Oh, sorry, not setter function, a getter function. So it's an accessor function. It gets information from the class and exposes it out to the public. So in this case, we need an accessor for x because it's a private variable. This class does not have a setter function, so I have no way of setting x after the initial constructor runs. I could do that by writing a set function, that would be something like void set x, and then it needs a parameter of some sort, so we'll just say again some var, and then we can say that x gets var. Like that, okay? What's the difference between public and private? Public, you can access from anywhere, like outside the class, inside the class, in the derived class, no problem. Protected, you can only, it works like private for the same level, so like you can only access inside of the class, but the advantage is that in a derived class, you can still access protected variables. So it works like private, but with the benefit of being able to extend it to derived classes. So that can be very useful for when you're trying to keep variables safe from the public, but still be able to modify them, not just in the base class, but in derived classes. And as I said, public, you can access anywhere. Inherit, out derived, the same class, out in main. By public, I'm talking about like outside of the class, So anyways, because of that, this variable x is private, meaning that I cannot access that variable, like from main. I have no way of accessing it. I can use getX, but I cannot, unless I have a setter function, which I didn't have, I added it to show you, I have no way of modifying x, okay? It's secure because it's private. I also can't print out x like this because, again, I can't access it directly. I have to call the getX function. So how do I get around that? Well, there's two ways you can do that. You can use pointer arithmetic, or you can use reinterpret cast, or a combination of them really. So let me show you how to use reinterpret cast for that. So what I do is I'm going to make a struct that has the same organization as the class that's private. And by that I mean it has the same amount of variables, and the variables are the same data type, and then the same order in your compile code. So in this case, we have class A has an int y and an int x. So I'm going to go ahead and make a struct, nicely called hacks, and I'm going to have an int y and an x. Now, I don't need to name these y and x. I could have named them j and k, but I'm doing that because it makes it more obvious which is which, okay? Once you do that, and by the way, notice something. I am literally making this struct inside of a function, in this case, main. You can do that. You can declare classes and structs inside of functions. They don't have to be in the global scope. However, the limitation of doing this, and why we don't typically recommend you do this or even show you to do this, is because when you're doing something in the global scope, you can access it anywhere in your program. But if I declare this struct inside of this function, the only place the struct can be used is inside of this function and after that declaration. So like pretty much only here. Okay, if I try to make an object of that struct here, it would not work. So that's why we don't typically do this. But in this case, It happens that I don't need to use this struct anywhere else but in main. So I went ahead and put it in main because it's kind of convenient. Okay, so I'm going to go ahead and make an object of this hacks class just to show you that it works the same way. And I can go ahead and set y, and I can print out y. So it works kind of the same as this, but it's its own object. Okay, so anyways, the cool part is the following. I'm going to make a pointer of the class hacks, which is the struct. This pointer just pointing to whatever. In fact, we can even be good coders and initialize it to null. Okay? Now here's the cool part. If I try to make hacks, a hacks pointer, point to an object of A, which is the class that has the private that I'm trying to access, I'll get an error. I'll get an error saying that the cast is not allowed. In fact, let me go ahead and show you that. So if I run this and I say pointer hacks point to the class A, like doing this. If this hacks thing, if this HPTR was actually a pointer of type A, this would work just fine. In fact, I can just go ahead and put an A here and that would work just fine. But by putting it's a hack, this is not a good cast. I would get an error. Let's see if we get that error. We might get other errors too, but we'll see. Compilation error. Cannot convert A to hacks in assignment. Okay? So what that is saying is that it's invalid to cast basically this pointer, or to basically cast the address of this into a pointer of hacks. Okay? So how do I get around that? Well, I can try dynamic cast, which is going to allow the code. Well, actually, no. In this case, it wouldn't even allow the code to compile. I'm probably going to get the same error. But let's go ahead and try it. Because we know that dynamic cast leaves some of that checking to runtime. But in this case, there's no shared parent class that would allow it to ever work. So that's why I believe with dynamic cast, it won't compile. It'll give me something similar. Error, cannot dynamic cast address of A of type class A pointer, which is correct. So technically speaking, address of A is an A pointer because with the address of operator returns to you an address. So the way that the compiler interprets that is basically a pointer. So it's a pointer of type A star, or just A, sorry, to the type hacks star, so hacks pointer. So can't cast an A pointer to a hacks pointer. And this is pretty cool here. Source type is not polymorphic. So what is polymorphism again? Polymorphism stands for multiple forms. Polymorph. So poly, multiple, morph being different shapes or forms. That's again the concept of polymorphism that we talked about with object-oriented programming is basically that you have this superclass that is derived between multiple classes with the idea that you call a function in your class, and depending on which class it really, which type the object really is, it will call the correct function, right? And having that flexibility is the concept of polymorphism, okay? And this is known as runtime polymorphism. Compile time polymorphism could be as an example, function overloading. You have a function called print, which oh, you scared me. My dog. I don't know. Maybe something scared her. So yeah. So for example, with print, printf is a function, for example, in C that allows you to print different things. So imagine that I wrote a print function that takes an integer and also takes a string. Different parameters, right? It's the concept of polymorphism in the way. And then when we talk about templates, I think 2 weeks from now, that's going to be another type of compile time polymorphism that is very cool. So anyways, this is not the last time we see polymorphism, okay? But you should know a little bit about it for the test. All right, so back to this error. Basically, it says it's not polymorphic, which means that you really can't cast this to this, even with dynamic cast. So dynamic cast is out of the question. Finally, that brings us to the Yolo Cast, which is reinterpret cast, which is that cast you can do whenever you feel like it. And then it will just cast it and hope for the best. This will work. This will compile because it's basically telling the compiler, I know this is horrible. Don't worry about it. I got it covered. And yeah, I do got it covered in this specific case. It's the compiler's basically trusting you. So it compiled and it runs. Okay? So once I went ahead and cast it, so now what I have is I have a struct pointer, or this hex pointer that is pointing to the object of A. And I can go ahead and run this line of code. This line of code is basically saying modify the X variable inside of this object to 42. But wait a second, isn't this private? Isn't this a private variable? Well, yeah, it's a private variable, but here's the thing. Remember the thing that we saw with virtuals. The thing that we saw with virtual was not, the compiler gets fooled easily. If you have two classes, you have a parent class and you have a derived class or a child class, okay? The parent class has a certain function and certain variables. And then the derived class has additional functions, possibly some of the same functions as the parent class, but modified, overridden basically, and extra variables, right? And so, with a function the same name between the parent and the child class, if you don't write virtual, the compiler calls a function of whatever the pointer type is. So if you upcasted a pointer, which means you had a child object which is now being pointed at by a parent pointer, when you call that function, it's going to try to access the function from the parent, which is the wrong function technically for that. So it's going to run incorrect code, right? So that was the issue that we saw with virtual, because virtual says don't do any compile time binding, which is what this is, at compile time. So don't associate function calls with certain pointers, because we don't know if the pointer is really pointing to that type. It could be pointing to any derived class. It can't be pointing to other stuff, because technically we're not using reinterpret cast, but in that scenario, but it could be, I suppose, as well. So with virtual, it says at runtime, figure out what this object really is, and then go look up in the B tables what the function should be for this. Okay? So we're basically taking advantage of that issue and exploiting it, essentially. Because now, once we went ahead and casted our hack or pointer of, we have a hex pointer and that was pointing to an object of A, now the compiler's like, this line of code should compile just fine, because he's just accessing, a variable that's public. So that's okay. So the compiler doesn't stop you from accessing a private variable because it thinks that it's a public variable, because struct has all of its variables public. I could have made this a word class if I wanted to, by the way, and then wrote the word public here. Same thing. The reason I did struct was less lines of code. Okay? But yeah, so doing that, I can not only access, but also modify. And who am I modifying? Well, hex is really pointing to an A, so I'm actually modifying the A's X. So now, if I call the get function again from A, I get 42, which is exactly what I modified up here. So I have shown you now how to modify a private variable. So you just hacks the program, I suppose. Okay? So that's pretty much all I want to talk about that. In the other eras, when I was doing the assignments, you had an assignment where you had to do this. It was really cool. I liked it a lot. But we're not doing that one, so sorry. But yeah, it's called Crack the Vault, and you have different vaults that you have to hack. One other way that you could have done this, by the way. So it has to have the same name as the private variable. It has to have the same ordering. So like, there's two integers in class A, so there should be two integers here. They don't have to have the same names, y and x, but you have to keep track of that. So I could call this like fake x, and it would still work as long as here I put fake x. And see, OMG 42 means that it worked. OMG 42. See? So the names don't have to match, but it's convenient for them to match to make your life easier. But there really shouldn't be a reason you're actually doing this, to be honest with you. Again, for this to work, you need access to the source code, which means, this isn't really like a hacking thing, because like you wouldn't have access to the source code in a real situation like this. But the concept is the same. Okay, so while we're at this, I am going to, and this is a new link, by the way, for the one that we're just modifying. I want to show you one more way that we could access this. So if we go ahead and trying to think of how to do this. I think for this one we'll do on the, so I'll just copy the code here and post it here. And then your code goes here. Okay. I don't remember where that came from. Hold on, I gotta get rid of the extra mains. Here we go. Okay. So I'm going to go ahead and get rid of, actually, so that I can give you a copy, maybe I should leave it be like this. Let's see if this compiles and runs still. Yeah, so I'll leave this be. So you have a copy of it on the list of files, and I'll make another copy. This one will be mid3. This one I'll modify. So I'm going to go ahead and delete all the hack stuff. Oh, so essentially pretty much everything. Okay. And then we're back to square one. So let me show you another way that you could access this variable. Y is public, right? I'm not asking y is public. I'm saying the variable y is public. Okay. So because it's public, I can get it to address, right? All I gotta do is say cout address of a.y. The dot has higher precedence than the ampersand, so this should be okay. All right, so that's the address. Every time it changes, but that's the address essentially, okay? So, pointer arithmetic time. What happens if I take that address and I increment it by 1? And just because I'm not sure about order of precedence here, I'm going to go ahead and do it like that. Well, I guess it works, but you don't see it. So maybe let's put 2 cout statements. All right, we're at the 20-minute mark, so we're almost done. So I'm going to show you that this gets us both the address of y and the address after y. So remember, virtual memory means that all of these variables in the class are stored next to each other. So if y lives at address b0, that's the last part of the address, then x lives here. So if this is x, then what happens if I just dereference that address? I get 5, which is exactly what is stored in, well, is it actually? I thought I put 2 here, into x var. Huh. All right, I got a different variable. That's funny. So maybe it's stored in a different order here. Let's see. Okay, let's cheat and look at where that's stored. So let's write a function that actually gets us the address. Get x address, return ampersand x. Okay, so let's see, cout, or not cout, just, I'm mixing things here. I just really need to cout it here, that's all. Yeah, and then I can just call the function. So let's see where that lives. That lives at address C4. And this address right here is C4, is it not? Get rid of the dereferencing. Oh, I think I know what I did here. I should have dereferenced after the +1. That's probably what happened there. Yeah, I see. So my thing was working. It's just that I screwed up pointer arithmetic notation here, because what I had before, I'll leave it commented out as bad, was that I closed the parentheses here. So I was dereferencing this pointer, which is pointing to whatever y contains, which is 4, and then I was adding 1 to that value, which is 5. So that's why I got 5. What I was trying to do was not increase the contents of 4, the contents of what 4 gets you, but the address of 4 plus 1, so get the next thing. Yes. Yes. So yes, what you said. Maybe there's a delay. I already figured out. But yes. That's good that you caught it too, though. I'm glad. This is good. It means you know your pointer arithmetics. So yeah. So there you go. Here's another. No reinterpret cast needed this time around. And all I really needed to know was the location of where yeah, that's what I thought. Of where x was within the class, which is immediately after y. Okay? And this was another part of the assignment too that was pretty cool. But yeah, so essentially Maybe if everybody does really bad on the test, I can give you this extra credit, this assignment or something. But yeah, hopefully everybody does good on the test. But yeah, so again, you need to know the structure of the source code here to be able to do this. But this is a little bit more of how, like, I suppose real hacking would work, in the sense that you need to locate where in memory certain variables are that you're interested in, and then once you know the location, you can just access it and play with them. But you have to basically be able to work around the safety measures of the security system, operating system, which are not that safe, I would say. And that's how, like, an injector works essentially for like an aimbot or something else. So when you code your aimbot, that's how you do it, I suppose. So that's it. That's all I wanted to show you for that. Function pointers, I have it written there mostly so that you can look at it on your own time. So let me locate that. Give me 1 second. Here we go. Function pointers. Go to that link. This is a Canvas page, so you can look at it on your own time. This isn't necessarily going to be anywhere that I know of, but it's still a cool thing to know. And just like you can point to variables, you can point to functions, and you can make pointers to functions, which means you can have one function with multiple names that are all pointing there. And so you might be thinking, like, what the heck? Why would I ever do this? Well, suppose you're writing a game and you have different procedures that you want to run. By using function pointers, you can create a queue of these functions that are supposed to run, and then basically throw them in. In fact, that's one of the things that I'm planning on eventually doing for 302. So since you guys are in 202, by the time you get to 302, that might be one of the assignments you get to do. So if you take it with me, that is. But yeah, so it's some example code here. I believe here what I'm doing is I'm making a fake print function. You know, a fake, I mean an alias. So yes, we're gonna hack Warzone. So yes, this is why I beat you in Warzone, actually, because I coded my own aimbot. No. That would actually be way too much work. And if I did, I would actually probably sell it, not just use it myself. Like, why would I want to just... It's a lot of work. So anyways. But yeah. So anyways, check this out on your own time. It's a cool concept, function pointers. It's just very niche, which is why I don't really spend time on it. But I want to make you just aware of it. So anyways, we overlapped 8 minutes of what I really wanted. But now we can talk about the exam. So what I'm going to do again for this is I'll take questions first. And then when we run out of questions, which hopefully will be like in 20 minutes or something at least, then I will, since I don't want to confuse people in future generations, I will end the YouTube link, but I'll keep the stream on Twitch. And then I'm going to go ahead and look at the question banks that your test is coming from, and I'll scan them and I'll point things out that you should probably look at. Okay? So, yes. So shoot me your questions then. We got 20 viewers, so we'll see. And again, if there are no questions, then I'll just start going over the test, but I will end the stream because I don't want to confuse people in the future that watch these videos and think that the same test will be there, because it's different. So there's the part where I sit and wait for questions for a little bit before giving up. Virtuals, will they be on there? So, the thing with virtuals, it seems, is that this time around they will not be in this first test. They are going to be in the second test. They were scheduled to be there. We had questions prepared for them, but it turned out that they decided not to be there. This was on my recommendation channel. See, that's strange. This is like a random class from a random university in a random place in the world that's doing online learning. UNLV, Las Vegas. I have like slot machines next to me, and they're all ringing right now. Yes, but they have a test on tomorrow, and this is their plea in the hopes that they will get some of the answers for the test. At what time is the test? The test is at your designated time, which is that 1 p.m. class tomorrow. It's C++. They are learning object-oriented design or object-oriented programming in C++. It is indeed very easy, but they seem to find it a little bit tricky. They just learn what pointers are, though. To be fair, learning pointers for the first time can be a little bit scary. Do you know around how many questions we will have? That I will go over in a little bit once I switch over to the test. But I do believe the way we did it is we created a test banks of multiple questions, and we pull 5 questions from each topic, and I think there's about 4 topics. This is a first year, second semester course. So this is like, they just started programming. Well, even though it's fall, I suppose they must have taken the 135 in spring. So yeah. I mean, after this class, they should be able to code something in C++, like some decent stuff. But like, yes, good luck to them indeed. MIT does this courses like in one semester. They do like 3 courses here, so it's a little slow mode, but whatever. And good luck to you too. Stay safe wherever you are. So you mentioned the test is open notes. Yes, the test is indeed open notes due to the fact that remote learning does not really give us a chance to be very strict. I did try Lockdown Browser over the summer. It's very easy to circumvent, so there's no point in trying it. Is there any concepts that you guys want me to go over? I mean, we got inheritance, pointers, classes, multiple inheritance. Virtuals, like I said, are probably not, they're most likely like not on the test at all. Can you explain static variables? So that's a good one too. I do feel like people would like to hear that one. So yeah, static variables and the differences between function overriding and function overloading. I like that question. That is a good question, which I'm actually like 99.9% sure that is going to be on the test. So that's a good one right there. So we got statics and overloading versus overriding. Cool, that's a good one. And then we got, how about the coding questions? So right there will be on there. Oh, okay, that's just a generic thing. So I don't think there's that much coding. I think it's a lot of concept stuff, to be honest with you. I know over the summer in 202, I gave them a massive programming question. It was Thanos related. They had to make the infinity gauntlet, and each of the stones was a pointer. And so they had to change pointers basically to make them, link them to the gauntlet to be able to do the snap, which would check that all the pointers are not set to null. It's pretty neat. Pretty simple too, but very neat concept. I like that question a lot. I would love to put that again, but I'm sure the solution is on the internet now. How about the arrow versus the dot? That's a good one too. I do remember somebody had a question about that some time ago. And then the end is near. Okay. All right. So let's start with these and then think of more questions in the meantime. Okay. So let's start with the easy one, I suppose. Well, easy being a little bit of a easy to explain, not necessarily easy concept, because that kind of downplays somebody's question. But overloading versus overriding, that's a good one to easily explain. Okay. So function overriding comes into play when you're using inheritance. So normally, if you have like a class A, and in this class we have a function foo, and this function does something. Doesn't matter what it is, but it does something, okay? If we go ahead and create a class B and maybe make it public. If we go ahead and make a class B that publicly inherits from A, if that's the entire class right there, well, let's say we add some other stuff, but nothing with foo, then this is your typical inheritance that you're doing. And if you try to call foo when you make, if you're in main now, and in main you make an object of A, and you make an object of B, and you go ahead and say a.foo or b.foo, they're calling the same function, right? Okay, so suppose you want to upgrade foo to do other stuff because you have these extra variables that you want to handle. Basic example of that, say, was a print function. And in your print function, you wanted to print out all of the member variables, like a nice little like summary of things. So in B, you have extra stuff, so you want to modify that function. So what you do is you go ahead and rewrite the function here. You say void foo, and then you write, basically the same stuff as here probably, or it could be completely different. It doesn't really matter, but you write stuff in there, okay? The act of you writing the function foo again is overwriting the original function foo. It means that the original function foo will no longer be used when you're creating objects of B. So this is going to be using, if I label them, we'll call this like the purple function or pink function, I don't know what that is, and this is the green function. This call is the green one, and the other one is the pink one. Okay? So that is overwriting. And by the way, going back to virtuals again, this would be an issue if you were using pointers and doing up and down casting, right? Because it would call the wrong function. But anyways, that's overwriting. Now let's talk about overloading. Okay? So overloading is the act, and this doesn't necessarily have to be in a class. This could be just as a global function. Let's say that I have a function bar. Maybe this function takes nothing. And again, you do random stuff in there. It doesn't really matter. Now, because it's a global function, you only really have access to global variables or local things. So maybe it says like hello world or something, whatever. Okay? So suppose that I go ahead and write on the function bar, but this time it takes a parameter x of integer type. I keep writing these semicolons because I'm thinking it's a class. It's not going to really make a difference, but I'll get rid of them. So yeah. I just do that because like I've forgotten so many times to write the semicolon up here that I just keep writing semicolons everywhere now. So yeah. Okay. So in this case, maybe this function says hi, but it also says the content of x and maybe an end line. Okay. Here you have two functions, which both of them you can access. The way that the compiler resolves which one you are accessing is if you say bar, or you say bar 5, or you say bar C, it has to figure out which to call. So let's say that this one is this beautiful shade of yellow orange. That is going to be called here. However, we got ourselves our nature green here. This one is being called when you call this one, or actually this one too. What's happening here is coercion, right? This car gets coerced into an integer so that it works on this one. This is overwriting, or sorry, overloading. Okay, this is overloading, as I wrote there. Function overloading. Think of the word overload like you are filling more stuff and more power to this function to be able to handle more stuff, basically. And what it is it's able to handle different parameters. And you can do this by adding more parameters or the same amount of parameters with different data types. And the issues associated with function overloading are ambiguity issues. So if I went ahead and had a function here that took an integer and another integer, or let's see, an integer and like a double, okay? And then I went ahead and had a function that was integer. So here, I'll just write them very fast. So let's say we have function b that takes an integer x and maybe a float y. And then I have the same function again, well, overloading it. And this one takes maybe, let's see, it takes a float here. But, well, let's start with something like this. It takes another double. It takes a double, okay? So in this case, if I have a function call to something of the form b5 10.5f, that's easy to see that it's going to go with this one because this is an integer and this is a float. The problem arises when the compiler can't figure out which one you're trying to call because two of them have the same sort of distance from your parameters, when the case of the parameters are not exact. And by the way, with overloading, You cannot have two functions with the same name and the same parameters. And by same parameters, I mean the same, I believe it's called signature of the formal parameters. So if I have a function b with an int and a float, I can't make another function that is like b with an integer. Even if I name it something else, like float c, that's not going to work. Okay, so that's a no-go right there. It has to be different number of parameters or different types of the parameters. Do you know that we're going to be testing through Web Campus? And if we do we have to write code through that one description text box? Yes, to both of your questions. Test is on Canvas, Web Campus as you call it. And if you write code, it will be on those text boxes. My recommendation for that is to go ahead and use the pre-formatted thing. Or better yet, write your code in an IDE, copy paste it once you finish coding it into a pre-formatted text box so that it doesn't mess up the tabulation. If you know HTML, you can go into the HTML mode and write the following tags. And then just copy and paste your code directly from your IDE here, and it will maintain the format for you. With one exception though, HTML will eat your hashtags, or sorry, not the hashtag signs actually. It'll eat your less than and greater than signs. So like your includes will lose that thing. If a class with a protected variable, say X, and I create a child class, let's call it sunglasses. Then again, I create a child class of B. Do I have X in this third class? So my question here is, are protected variables available on So protected variables are available, basically, if you have a superclass that has your protected variables in it. So let's say it's called superclass A, which then gets inherited to B and C, maybe a D down here. If you have any variables here, they exist in all the classes. Now the real question is the accessibility of them. So when this is protected down here, up here, what ends up happening is it should be available to these. However, you got to make sure that you inherit publicly or protected so that the protected tier remains. If you don't inherit publicly or protected, then it will be converted into private and it will not be able to be accessed by the grandchildren classes. Okay? So like when you're doing your class B declaration, you would say class B colon, and then you have to put either public here, and then A, or protected. Protected, if I can spell it right. If you don't put anything here, if you just put it like that, it'll default to private, and then you will be in trouble. So I believe that's basically the way it works. It will continue to flow into the child classes as long as you always inherit public or protected. So, yeah. We have questions went all the way out of the chat here. Say you have a class B and A with a B inheriting from A. Okay. You guys are spamming with questions, but I still got to do the ones that you guys already asked. So hold off on the new questions until I finish here. Okay. So anyways, this is overloading versus overwriting. And then we needed to know the arrow versus the dot. Let's do that next, and then we'll do statics, okay? So for the arrow versus the dot, the arrow is useful for pointers, and the dot, first of all, let's talk about the official names of this. They're called the member access operators. And this is known as the arrow, and this is known as a dot, okay? So dot member access operator or arrow member access operator, okay? So, yeah, okay. So if you have a class, so let's go back to our classes that we had up here. So we have a class A and a class B. So let me maybe copy and paste this down here. So we got this architecture here, and or organization is a better term. So I can make an object of A like this, right? This object lives in the stack. It is what we consider static, but not to be confused with the concept of static variables or static functions, which we'll talk in a second about, okay? Static in the sense that it's living in the stack and it is created when the program starts running already. It's been defined. Alternatively, you can dynamically allocate a class object by using a pointer to store it. Actually, you don't need to use a pointer, but if you don't, you're going to lose it. You know, you can just write this out, and it's just going to make an object and then just throw away the address, which means you just made it in memory leak. So here you have a pointer of this. Okay, so both of these are basically objects of A, and they both are contain a foo function. So alternatively, if you want to deal with pointers but not deal with dynamic stuff, you can use the. Oh, by the way, I suppose you might want to name these different so you can code compiles A1 and A2. But if you want to make A2 point to A1, then you can do something like this, right? So you can still deal with pointers even if you're not dealing with dynamic stuff. But typically, you will be dealing with dynamic stuff if you're dealing with pointers, because otherwise, you know, I mean, there are cases, but it would be strange, unnecessarily complicated. So yeah, okay, so you got this going, and then let me go ahead and try to access the foo function, okay? So with a normal object like this, I just use a member access operator, the dot, and I can write foo like that. And now I'm accessing the green foo, okay? However, if I try to do that with a pointer, it will not work. And the reason is because the pointer is just an address, okay? However, the pointer contains an address, but it's not itself at the right spot. So you need to dereference that address. So you basically tell me, what is the address that the pointer holds? Get that address and then go there. And then that is going to be basically pointing to the top of your class. So again, if you think of memory, you can think of your object as being right there, okay? And as I was talking about earlier with accessing private variables, you know, all your variables are nicely stacked on top of each other like this, you know, your X and Y and whatnot. You also got your references to the functions, I guess, in a way, and so on, right? And so really, you know, what you're getting when you have a pointer to a class is pointing to the first entry or element in this class, okay? So what I need to do is, when I have a pointer, is dereference the pointer so that I can get to that little arrow there. How do I do that? The reference operator, which is the ampersand, but the asterisk. However, order of precedence comes into play here. So thinking to the example of math, imagine that I have the following operation in math. I have 2 times 2 plus 4, okay? This is exactly what's happening here. The dot, I don't like the fact that I'm using an asterisk because you're going to confuse that. So maybe we'll say 2 divided by 2, okay? Yeah, we'll do that one, all right? Now we use different symbols. So we got 2 divided by 2, and we also got 4, okay? Mathematics tells us that we have to do division first before the addition, right? Operator of precedence. Order of precedence, not operator of precedence, okay? So theoretically speaking, this should be 4 plus 1, right? Which is 5. Now, if you do 4 plus 2 first, which is 6 divided by 2, you get 3. So you get a completely different answer if you don't follow order of precedence. So that's kind of what is happening up here. We need to make sure that the dereferencing happens before you access the member. So we need to make sure that the asterisk runs before the dot. But right now we have a situation of like 4 plus 2 divided by 2. So how do I guarantee in math that I can do the addition before the division? Well, the mathematics gods have granted us with these curved lines called parentheses, right? Exactly. So in this case, we wrap parentheses on that, and now bam, all of a sudden, we do the math first, we do the addition first, and then the division. Same thing we're going to do here. We put the parentheses to make sure that the dereferencing happens before the, before going to the foo function, okay? However, the concept of doing this is kind of nasty looking, okay? And if I had inside of class, let's say that there was a class G, and class G, I don't know, had an int x in it, and I suppose public. So here, let's make it a struct, so I don't have to write the word public. Okay, and let's say that G lived here like that. There's a G called, let's actually make a G dynamic. Okay, I believe that will compile in std11, C++11. So anyways, we got a pointer that is pointing to a dynamic object of the G struct, okay? So suppose that we need to access that. In the first scenario, with the non-dynamic thing, we can go ahead and say A1, and then G dot, is it X? forgot already. Yeah, it's X. However, same issue arises here. G is a pointer, so this will not work, so we need to dereference that. So you got to make sure that this happens first before the X. Now here's the thing. Do I need more parentheses here? I do not, because now I actually take advantage, because in this case, you know, I have the 4 plus 2 divided by 2, but in this case, I actually want the divided by 2 to happen first before I do the plus 4 part. So I need to make sure that I go to G, and then once I go to G, to dereference that to get to X. So in this case, I don't need those parentheses. I do need the exterior parentheses because once I get to G, I do have to dereference that. So I do have to put that asterisk there, which would be like if I had a 2 plus that. But in this case, I want to make sure that it happens like that, okay? So I guess when in doubt, think of basic math. And if you can't think of basic math, then there's always I'm supposed to pray or something, I don't know. Okay, so yeah. Now, let's go ahead. Wait, no, what am I doing here? Hold on. I have too many asterisks here. Hold on a second. I did not need this one, actually. Not in this one. I was confusing it with the next example. But no, I don't need that asterisk there. That is fine enough as it is there. Okay? And I don't need... Yes, like that. Those I do need. Okay? So anyways, now let's go to the harder one, which is A2. So A2 is a pointer. So A2 is pointing to G. Well, no, sorry. A2 has a member variable that is a pointer called G. And G has a member variable, which is X, okay? But in this case, both are pointers. So I'm gonna mix and match basically what I've done here. So the A2, I still need to have its own set of parentheses like that. And then the G has to have its own set of parentheses like that. Okay? And that will be the way how I access that. As you can see, this becomes a mess very quickly. This is where the arrow operator comes to the rescue, essentially. So we got A1G, or I'm so confused at this point of all the variables. Let's just look up here. So this one, let's look at this one right here. Copy and paste this one. This can be converted into just that. Arrow operator to the rescue. Arrow operator ensures that there's dereferencing happening before accessing the member variable. So whenever you see the arrow, it's basically the equivalent of the above line, which does two things. It dereferences the left-hand side and then accesses the right. So it assumes that A2 is a pointer, dereferences that, and then goes to foo. And then this bigger, more complicated example here, so this one becomes A2 arrow G arrow X. Look how clean that is. I mean, compared at least, all right? So that's arrow versus dot. That's all I want to say about that, really. I mean, a cool exercise that we experiment around is, what if I want to convert A1 dot foo? That's correct code. What if I wanted to use the arrow operator here? So what if for some reason I just love the arrow operator and I hit, or like let's say the dot key is broken in my keyboard. So like I can't use the dot key. So how do I get around this? Buy a new keyboard? Yes, that would be the easy solution. But there's another way of solving it, which is a little tricky. Is I can use the arrow operator even when I'm not dealing with pointers. However, here I kind of got to do the opposite. I have to get the address of A1, and then now I'm passing a pointer to this, which means that when it dereferences, it'll cancel it out. Because technically speaking, if I have a pointer, let's say PTR, and I go ahead and I dereference that pointer, and then I get the address of the pointer, and then I dereference it again, or in this case, it's the same thing as dereferencing because these two things cancel each other out. Okay, they're like antimatter versus matter. They just disappear. Okay, so anyways, I highly doubt that's in the test. But, I mean, the dot and the arrow are in the test, but I highly doubt they're gonna make you do this. Actually, I lie because I do think that was one of the questions that I submitted. So I don't know. So you might actually want to make sure you know that. That's a good point. I can't remember if I submitted that as a question. But yeah. I said, what if you want to switch it back? I think I did. So I'm kind of glad that I showed you that again. Okay. So finally, before the new questions that came, we have to go about statics. So I had created a little thing for next class. So I gotta scroll that down now. Okay, so let's just leave it there for now. Next time we will talk about overloading after the test. Okay, so with statics, you have to first understand the concept that every object that you make from a class, so like if you have, again, some class A, and this class is public. Actually, it doesn't really matter, but I always make them public just so I don't have to do getters and setters. You know, let's say they got an int x, an int y, could be strings, whatever. I just like using ints because it's fast, less to write. So every single object that I make of this class A is going to contain an individual copy, or not the word copy, an individual instance of an x and a y. Meaning that in memory, every time I make a little A object, it has a slot for the x, and it has a slot for the y. And if I make two objects, they each have an x and a y, and they're independent of each other. So I can store information on both of them, and they can be totally different. They're not connected at all. It's like they're siblings, you know, they come from the same parent, I suppose. Though don't think of the word parent because of inheritance, but they come from the same source, but they are independent of each other. Okay? They're just like family, but they don't necessarily have to share stuff. All right? So, statics, on the other hand, you can make a static class member variable. And what that means is that it's not going to be independent, but it's going to be kind of like the parties or a shared variable. So if I go ahead and here and I say static int p, and I think you can do static int p, or you can also do int static p. What that means is that there's going to be a p variable that is accessible by all objects of this type of class. But instead of being that each class has its own copy of p, they all just have a reference to the one and only p, which is shared. So if any of the objects, if I make like a1 and a2, if any of these objects change p, then it'll change for everybody. Now, why is this useful? Well, suppose you want to keep track of how many objects you've made of a certain class. You can go ahead and create a count, and every time that you make an object in the constructor, you can increase that count by 1. And in fact, you can use the current count value as an ID number that would be unique between each object, and also keeps track of when the objects were made in what order, at least. Not in what order, not necessarily one, because you're not getting the time. Okay? So I like to think, I think of statics as the community variable or the parties variable, right? Because it kind of, there's only one copy of it. So it's a very, very unique thing. Not unique, but it's very situational, I would say. So it's not used a lot, but it's definitely something that the higher ups, not higher ups, but the higher level classes have insisted that we make sure that we emphasize on, because people don't seem to kind of catch that on. Static functions kind of work in a similar manner, but they do have something that I want to point out. But before that, actually, one more thing I want to say about this. When you're normally calling a variable in the class, you have to use your member access operator, right? But when you're calling a static member variable, you don't even need to specify a specific object. You can say something like a scope resolution operator p. And you can also access it this way. And this brings up an important point. The p, the static variables, they exist even if you've never made an object of class A. They exist when the program runs. They're like a special form of like a global variable in a way, because they exist always, and you can pretty much access it anywhere that you could create objects of the class A. So if your class is a global scope class, like it normally is, except for that example I showed you in the beginning of class, it means that this is for all intents and purposes like a global variable. If you, of course, that's why you sometimes don't want to make statics public. You might want to make them private or protected. But I mean, fun fact: in C#, C#'s a programming language. It's more like Java than C++, but still made by, I believe, Microsoft. C# does not allow global variables, and the only way that you can simulate a global variable is to make a public static, and bam, you have a global variable. So that's kind of cool thing. So similar thing here. All right, I do agree with that. So C for cancer sharp. All right, whatever. So that's static variables. Static functions. So static functions work in the same manner that you don't need to access them with a direct object. You can do this system here. And static functions can only access static variables if in the terms of member variables, because otherwise, like if a static function tried to access a member variable, it'd be like whose member variable? Because it's a static, which can be called this way, it can be called without an object. And the big thing, that this is what they want you to know, is normally when you are, there's something called a call stack, which I might have mentioned at some point. When you call a function, it gets added to the call stack. Let's talk about in 326 in detail. The call stack contains a couple of things. Most importantly, it contains all the parameters that you have. So if you have a function foo, which has an int x and maybe like a double y, here's your int, and then maybe I guess a double will take 2 slots here, okay, 8 bytes or whatever. Let's say these are 4-byte increments. In addition to this, there's one more thing that a function, when it's a class function, will contain that a global function really wouldn't contain, and that is a reference to the object itself so that it can access all the member variables in the object. And this reference is known as the this pointer. And it's always passed as the first thing in this call stack. This address, the reason why you have it is because of what I was doing in the beginning of the class with pointer arithmetic, accessing private variables. That's what's happening internally. It passes, again, you have your class, remember, here, I'll just go up instead of trying to draw it again. You have your object that this class is being called upon. Sorry, that this function is being called upon. You are passing it that arrow so that that function has access to all of this. Because in C++, as I've said also before, you don't make a copy of the function, like actual copy of the code, every time that you make an object of that class. So if a class has a function foo in it, you don't have like 50 billion foos in code. You only have one. However, to be able to run that function and be able to access the member variables that this function is being called upon, it needs this pointer, literally called this pointer, this one, to be able to access those member variables, whether they're private, public, or protected, doesn't matter. It needs this pointer to be able to access that. So that is a normal function. A static function does not have the this pointer. So at address 0 in the call stack, you would say this is address 0, 1, and I suppose 2. At address 0, if this was a static function call, it would actually just have the int. And then at address 1, it would have the double, which would take 2 addresses, by the way. So if this was like a third variable here, let's say it was a string, then this one actually would be a 4. Okay? And in this case, it would be a 3. So that's a big difference. This is like 100% going to be a question probably in like CS326 in the test. Like, what is the difference between a static function call and just a normal function call in a class? And that is that the static one has a reference to the class as the first parameter, and the static one does not. Okay? So I'm warning you. If when you guys go take 326 and they ask you if you learned this and you say no, and then they come yelling at me, I'll be super angry. I will hunt you guys down. You guys better, if there's something you want to remember for that class, is this stuff right here. Okay? This and virtuals as well. All right. So that concludes statics. So now I'm going to go back to the questions you guys asked a little bit earlier. So arrow versus dot, colon versus colon. Well, I already talked about, so this is called the scope resolution operator. And it's used when you're accessing a namespace or when you're accessing something from a specific object. Like I just use it for the static. When you're, by the way, when you're declaring, when you're initializing a static, you can't initialize it in the class. So you have to put it outside the class. So like for example here, I would have to write something of this form: int a : p equals, and then maybe 0. That's what I'm going to initialize it to. And even if it's private, you still got to do that outside the class. It's kind of one of those weird exceptions to how public and private work. But you can only do it one time, so you can't like reinitialize it. And then the single dot is typically used for inheritance, like when you say class A inherits, well, probably class B. And then this means inherits from something else like A, but in here you want to put a modifier. Otherwise it'll default to private, which you probably don't want. You want public or protected, most likely public, so you can keep the status quo per se. The other usage of that is again with a constructor, that you're going to put it after your parameters, but before your body of the function. And what you can use here is it's called the initialization, or initialization something. I can't remember the name. But like if you have if your class has like an X in it, again, this is where you would do that initialization there. And I think I went over that in the beginning of the video today. Let's see. So now next, say you have a class B and A with B inheriting from A, yes, and you're making a B object. If you want the B constructor and the A constructor to both run assigned variables, member initializer list, I think that's what this is called, by the way. Is the member initializer list the only way to do it? The only way that I know. I can't say it's the only way for sure because there might be other ways. But yes, suppose that normally by default, it's so convenient that I like have this set up with the same names. But normally, what happens when you run code that has this sort of structure, like we have an A class and a B class, if you were to like write a simple piece of code that just has two classes, write a default constructor for both classes, put a cout statement in them, call it like constructor A, constructor B, run the code. I did this in the summer. You can watch that video if you could find it. So if you do that, and then also put a cout statement before and after, I suppose, that the in main where you're actually initializing an object of B class, okay? So then, put cout statements here and cout statements here. If you see that, you will see kind of the order of how things get run. But you don't see the full picture if you're not careful, because the way it runs is, first, you'll see that the constructor for the parent class gets run, and then the constructor for the child class gets run. So you would see that the cout constructor A would get printed out before cout constructor B. But the real ordering of how things go is like this. When I'm running this line of code here, first, this runs, which means any default parameters that were not passed will get assigned to whatever the default value is. Those will get all populated. And then this runs. And this in here is when the constructor of the parent class will run. So if you go to the constructor of the parent class, by the way, this should be B, not A. The constructor of the parent class, again, will first go ahead and run this part if necessary. And then if it has anything here, it'll run. Then it'll run this. And then it'll finish, and then it'll come back to the B constructor. So now the B constructor just finished running this part, so then it's going to go ahead and run the body of that. So it's an interesting kind of intricate way of doing that. The reason this does that is so that things get initialized in the correct manner. So yes, if you want to call anything but the default constructor, the only place you can do it is here in the, as you very correctly mentioned, the member initializer list. So if there's a constructor that you want to call that's not default, maybe takes a parameter like this, you have to do that in there like that. And then it'll get called correctly. So I don't know other ways. There might be, maybe in like modern C++ there is, but I frankly don't know them. It's like I know one way it works, why learn more, I guess. I don't know. So yes. Okay, so that's a good question. I'm glad you brought that up. If I have so I answered that one I think already. If I have class with a protected variable, say X in the create child class, let's call it sunglasses. I think you meant C. I don't know. And then again, I create a child class B. Do I have to class? So I answered about the protected one. I'm pretty sure defining B's constructor like BA can run a constructor, but I wonder if there's another way to do that. So we kind of talked about that, so I don't know if there's another way of doing that other than this. Especially for this comes a big issue because I have no other way of knowing how to call a non-default constructor when you need to do that. So you're kind of stuck with this unless there's other ways. If you define a class struct with a static variable inside a function, will the static variable keep its value if you go out of scope and then run the function again? Yes, it will. Yes, it will. Very good point. So, like I said, static variables in the class are created when the program starts, like right when the program runs. They exist and persist, even if there's no objects made, or even if all the objects have been deleted and whatever, deallocated, it'll still persist until program termination, which means at any time I can go and access it, modify it, and whatever. That's why I said like it really works like a global variable in a way. So that's a good question too. Okay, we've caught up now. So continue with more questions now if you have. I'm going to take a water break while you guys think about questions. Anything else? You're all freaked out? Who knows? But anyways, not like 22 viewers, but like 2 people asking questions. So interesting. Memory leaks. What about them though? Like, I guess I'll show you an example of how to make them, but unless you have anything specific that you want to talk about memory leaks. So, this is me making a memory leak. Bam, memory leak made. How do I fix this memory leak? Bam, memory leak fixed. However, this is weird and I don't know why I would want to do this. Better usage of that. Let's make a pointer. All right, let's allocate that pointer. Cool. Let's do something with the pointer. Cool. Let's deallocate the pointer to not have memory leaks. Bam, done. So, yep, that's all there's to it, unless there's something in specific that you want me to show you, because it's kind of a very broad subject. I suppose in addition to that, I should point out that a tool that is very useful for fixing memory leaks is Valgrind. Not fixing, but locating memory leaks. Fixing is all on you. And by the way, while we're at this, to avoid you like accidentally doing this, which is bad. And why is it bad? Because it's what is known as a dangling pointer. So to avoid dangling pointers, go ahead and set the pointer to null. So now your program will segfault if you accidentally try to do that. Which, well, actually probably when you try to run it, hopefully it gives you some kind of compilation error. What I meant is the whole concept of dynamic memory allocation. Well, the whole concept is you want to be able to allocate memory at runtime so that you can have the flexibility of using memory on demand and returning it before the end of the program. So it's good in that manner that you don't longer have to hard code. And the concept of hard code is basically putting a fixed number for a size of an array or something at compile time. You can make that be flexible based on the demand, and by that I mean the usage of the program. So if you need an array of size 10, make it. If you need an array of size 50, make it. But now you have the flexibility, so it's not always 50, so you're not wasting space. And you can, if you have a really, really big program, like Warzone or something, hopefully, you pull some memory to use for something, but when it goes out of render distance, then you can go ahead and deallocate it so that you can use that valuable memory for other things. And memory leaks are when things don't get properly released and they slowly build up on memory. And again, with a memory leak, what happens is the operating system gave you rights to use that address. They gave you permission. They're not going to give that to any other program until you return it. If you don't return it, then no one can use it. And if you don't have access to it because you lost the access, you lost the pointer address, then not even you can use it. So now no one can use it. And eventually, if you make enough of these, you're basically using the entire memory, but not even you can use it because you've lost it. So it's like you keep borrowing money, but then you lose the money before you actually get to spend it. And so now the bank has no money, you have no money, and all these money just like disappeared and lost. And eventually you run out of money and the whole thing explodes. I guess that's it. Okay. Will you be in VC during the test, just in case we have questions? What do you mean by VC? Like Discord? Voice chat? I will be available. So mostly, not necessarily for questions, but like if like everything explodes and like no one can fix it, you know? Like there's a chance that this whole test bank thing will not work and like I have to panic fix it apparently. So I will definitely be available for that. As for questions, my recommendation is just to do your best. If there is something like a major that you need to ask me a question, then yes, you can. You can send me an email, Discord message, not voice chat, but I prefer Discord message because voice chat is kind of like you have to actually connect, and writing is a lot easier. So if there's something big or major, then yes, I'll be like, share your screen or something. Like if like you have major issues with Canvas, again, mostly I'm there to make sure the test runs smoothly. Whereas, by the way, your TA is taking 302 tests right now, so hopefully he's doing good. Just thought about that. But yeah, but I'll try to see if also the TA is available there. But like, if you think a question is wrong, just do your best with it and basically bring it up at some point. Because normally, if I was giving a test in person and like we see a mistake in a question, I can tell everybody like, hey, this question is wrong, fix it, or don't worry about it. Can't really do that here because A, everybody's getting a different test because of the test bank randomization, and B, I can't really easily inform everybody of something. Like I could put a Canvas announcement, but people are going to be focused on the test. So it's just like, whatever, we'll give you points, and everybody else who gets that question, we'll figure that out. You know, that's the best I can do. So, but I will be available if things come up. But really, for questions, just do your best. Oh, already I think someone, think about it. Today's Wednesday. Some people are already taking the test right now. There's already things that this is good for us because all these issues are going to get ironed out by tomorrow. But like, I do know for a fact that some people have problems with matching questions where like the matching things were not showing up or something. And so they already like found a fix for that they're working on, I think. But yeah. So like, there's been issues already. But the good news is everything will be ironed out, hopefully, because we're making the other classes beta test the test. And we're like one of the last classes to take the test. So by then, hopefully, all the issues are ironed out. And if not, like I said, we'll curve the test or give you points back in questions that are like wrong. I think there was one question where it was true false and it was like the wrong answer was selected. So they they have to go and manually fix that. And yeah, like I said, I can always give you that other extra assignment as extra credit to help you out if you guys do bad on the test. So don't worry too much about the test. Do your best. And then think about it this way. You want to do better than your peers because then you're guaranteed a good grade. If you're above average, I would say that you have nothing to worry about. If you're below average, that's when you gotta kind of ramp up the work to catch up, I would say. So yes, that's kind of my advice. Okay, so since there are no more questions, what I'm going to do is I'm going to end the YouTube recording, and then I'm going to leave the stream on, and then put show on the side here, like not show you, but for me to see the test and see if there's anything in specific that I want to point out. Okay, And that's when I can tell you more about like the questions and things, the number of questions, because I'll be able to see it. So yes, okay. But for those on YouTube, which I'm assuming no one will be really watching this video because it's kind of, I mean, maybe like people in the evening, but for those on YouTube, thank you for watching. Don't forget to like, comment, and subscribe, I guess. But yes, I'm gonna run the outro and then we'll be back in a second. Thank you.